So now we have discussed on that performance analysis of concentrating collectors, cylindrical parabolic concentrating collectors. Now the energy balance are used to describe the performance of focusing collecting system as done with the flat plate collectors. So now consider a parabolic collectors to be shown to be here. Uh, so this is that reflectors area, that is a reflecting area to be mentioned to be here itself, that is a trough in the trough. So this is a observer tube. So that is a one is the observer tube, another one is that is the outer side is a glass cover to that is a reduction of radiation losses. So that is psi r is called as a rim angle. So that is a d naught is nothing but that is the outer diameter of the outer diameter of the cover. So there is an observer tube or a reflecting area, that is the entire length of the observer tube, and or otherwise called as a reflecting area to be here. So there is a fluid inlet, that is a fluid is inlet, and a fluid outlet to be here itself to be mentioned. So that the performance collectors, the performance of the collector described in the energy equation, like as that is a Q equal to HBRB rho gamma tau alpha suffix of UL and AR, that is a difference of TR and TA, the ratio of the area of collector, that is here HB and RB is the nothing but that is a beam radiation, that is a QU equal to useful heat gain per the aperture area, and HB and RB is nothing but that is a beam radiation intensity of the reference surface available for the solar date of the place. So the RB means that is the ratio of beam radiation of the reflector aperture. Whatever the reference surface HB is measured, that is means the HB and RB is beam radiation on the plane or aperture per unit time per unit area. So that is a HBRB, and rho is the specular reflectance of the reflector surface, and gamma is the interrupt factors and factors of the specular reflector radiation, that is the interrupted by the observer, and tau gamma is nothing but that is a effective product of transmittance and observance. So that is a transmittance of the cover and observance of the receiver. So and A and AR is nothing but that is a area of collectors, and AR is nothing but that is the area of receiver, that is the area of receiver, and UL nothing but that is a overall heat coefficient of the collectors, overall the heat coefficient of collectors or receiver, and TR is nothing but that is a receiver surface temperature at point X, receiver surface temperature at point X, and TA is nothing but that is a ambient temperature. So that is a, and the area means that is a flat plate characters in a flat plate characters, and A equal to AR, that is the area of collectors equal to area of receiver. So there is a maximum energy flux per unit area of the receiver may be that is a limited about 1 kilowatt per meter square, while in the case of focusing collectors, that is the area of collectors and the ratio of area of collectors and area of receiver may vary from the unity to, because it is having several thousands, the heat flux may be comparable to the convectional heat exchangers. So now we have the whole receiver of the uniform temperature to be applied as a TR. That is, equation can be written as likewise, that is a QU equal to the area of collectors and HBRB, that is a rho r tau alpha minus UL AR temperature difference of that is a TR and a TA. So this is a thermal losses of larger area of flat plate collectors because due to that large area losses involved. In a focusing collectors, by increasing of ratio of the area and area of collectors and area of observer with a fixed area of collectors and uniform heat transfers, losses can be reduced. that is the AR is decreases. Thus the focusing collector permitted a high temperature of the energy efficient. In a focusing collectors, it differs in a thermal behavior compared to the flat plate type because it having a receiver and shape are widely variable. The temperature are higher. The edge effect has more significant. The conduction term is are very high. The radiation flux is also having that's not uniform. Therefore, that is a possible to present a single gradient method estimating the thermal losses. However, the main feature of the trough collectors is out considering the representative parabolic cylindrical reflectors with the uncovered receiver. The generalized analysis of focusing collector system is similar to the flat plate collectors. So now that is a heat gain per unit length of the collectors to be written as form as a Q equal to area and let's say equal to area of the collectors and observer and HPRB and rho tau psi minus D naught U all temperature difference of TR minus TA, that is to be written as. So after that you have putting as a here that is a factors, that is a removal factors FR to be applied to be here. So and again for that, that is a removal factor means that is the ratio of actual gain and gain of collector surface surface wear at inlet temperatures, at inlet temperature, that is called as a removal factors to be applied to be here. So then the efficiency of the collectors to be attained, that is the equation to be collectors to be founded by the substituting the finally you get the efficiency of collectors, that is the ratio of QU and HBRB. So in this equation there is a shading effect is neglected, shading effect to be neglected. The same analysis will be followed to a receiver, that is a covered receiver is to be covered with the effective area of transmittance and absorption. A product the value is S. So this is some of that analysis, performance analysis of concentrate collectors to be implemented. So the here that is a maximum that is a temperatures to be applied to be, that is a efficiency of the collectors to be calculated from the reflected area only, and also here that is a neglected for the shading effect. So the efficiency to be obtained to be efficiency to obtain this likewise the equation, so Q and HBRB, that is finally to find out the efficiency of the concentrating collectors.